Hello, everyone. Good morning and good afternoon, where you are. Uh, we are going to be doing the Fiber Channel Industry Association's introducing fabric notifications webinar. We'll start in 1 minute so that more people can join. So stay tuned. We'll be starting in a minute. Thank you. Okay. Uh, Good morning and good afternoon, everyone. This is Fiber Channel Industry Association sponsored introducing fabric notifications from awareness to actions webinar. Uh, we have a great illustrious panelist of industry experts presenting the topic. The first one is Rupin. Rupin is with HPE working on fiber channel networking. Uh, he's one of the panelists, followed by Howard Johnson. Howard is with Broadcom, Broadcom's Brocade division, working on fiber channel for a long time. Both Rupin, Mark, and then the third one is Mark. Actually, let me talk to each person first. But Mark Jones is with Broadcom. He's also one of the panelists. Mark is with the Broadcom's FSN division or ECD division. Actually, I think I can correct me later on. The fourth panelist is Nishant Lodha from Marvell, Marvell's QLogic division. All the four panelists have been with the fiber channel industry for a long time, and they have at different times been presenting their companies, their or the fiber channel industry at different events. So very well-known experts on the topic at hand. And without further ado, I'm just going to basically go through a couple of early slides and then hand it over to Rupin and Howard to present. Uh, so, what is Fiber Channel Industry Association? Is basically we are a coordinating body focused on marketing fiber channel technology. The FCIA has been in existence for more than 25 years, promoting fiber channel technology since its inception. Um, it, all the all the members, companies that participate in fiber channel industry are members of the FCIA, and so we basically have a very good cooperative relationship at the industry. So because fiber channel is a standards based product, standards based industry, basically we can bring solutions much quicker to the market. They work with each other, so there's great interoperability and all. So that actually is one of the big advantages of having a FCIA driving that option of fiber channel. And this has been very successful model in getting more than 142 million ports shipped since 2001. So with the speed of 1 gigabit per second, actually, that was the connectivity to the current one running at 32 gig and 64 gig speeds, basically. So we have come a long way. Fiber channel is one of the is actually the highest utilized connectivity connectivity technology in the data center. It's still very stable, provides very high scalability, security. Um, it's just basically one of the leading networking technology, and it's still being developed with a lot of new exciting technologies coming to market to solve modern storage issues, storage networking issues. And so we're going to be talking about that today. One of the big ones in the data center is about automation, automating your operations, automating your performance, automating the solution to the performance, or mitigating your solution or performance bottlenecks through SAN automation. And the technology itself is called fabric notifications, and the experts, Howard and Rupin and Nishant and Mark, will talk about it. Uh, we are basically, the format of this presentation is such that we'll basically have a talk first, go through the slides, go through the basics of the technology, and answer the questions that you may have. Feel free to type your questions into the box there, um, into the question and answer box on the right. Um, we have we have some more experts join in the on the back end to answer those questions, or actually assign those questions to a panelist so we can get those answered live. If we can't get to those questions, the questions actually will be answered and maybe posted on the blog, or will be basically you will be able to see the answers to those questions later on. So without further ado, I'm just going to pass it on the ball to Rupin Mohan for taking us over the topic. Rupin.
Okay, thank you, Kiran, and thank you all for joining the call today. And we're going to spend some time talking about a lot of technical details around what have we been doing as an industry around SAN automation and SAN orchestration, right? Um, Fiber Channel continues to be the number one protocol for tier zero storage networking deployments, in the industry. I mean, we talk to a lot of customers, right? And every time a customer has a storage array that can go down, and they want, like, those five nines and availability. Fiber channel is the protocol of the choice, right? And it continues to remain very popular in the data center. And as an industry, we are working on the next generation speeds and feeds already. So in addition to the next generation speeds and feeds, we've been focusing a lot around what can we do around making fiber channel easier for our customers to deploy and manage. And as all of industry wide, there's a trend towards automation, orchestration, and getting the operating model for managing your storage arrays really simplified, and also reduce the cost of managing your SAN. So we've been focusing on solving these problems for our customers. Now, as you can see in this slide, right, you can solve the SAN automation orchestration problem at various layers in the stack, right? Different customers have staffs at different levels of knowledge and expertise. We find that the newer generation of storage admins are more DevOps type of people who like to write scripts and like to write some code, and who are the kind of people who want to be more hands-on in terms of automating and orchestrating their data center. For those people, we have a set of Ansible playbooks that you can download from GitHub, from various vendors. So it becomes very easy for you as a customer who's got a DevOps type of system admin, storage admin staff to write your own Ansible playbooks, and make those modifications. We have a lot of industry tools that the industry as a whole has developed, including my own company. You can obviously buy these titles, and you can use these software titles to manage your SAN. And by the way, these tools, all of them provide incredible value, especially if you have a staff that's not very technically savvy in the protocol, or a very large deployment. of a fabric, right, with thousands of ports, these tools can be very helpful. Um, if you have, again, if you have a staff that's, very comfortable writing Python scripts, I mean, we have a ton of Python libraries that can be, leveraged for developing your own custom tool set for your particular use case. In addition to that, now, when I see the next generation fabrics that have been recently launched, pretty much all the fabric components have a very robust REST API, a Redfish API, availability. So you can, also, write, C code, C++ code, Java code, whatever language you're comfortable with, in developing your own custom applications. In addition to all these, higher layer, solutions that you can develop for SAN automation, the industry standards, and especially Fibre Channel industry, has been really focused on what can we do inside the protocol, right? What can we develop in the protocol to solve some of these challenges? And by the way, Fibre Channel is very reliable, and we've solved, most of the easy problems. Now we are solving really, really hard problems. So the two biggest, complex things that we do in Fibre Channel is, one is zoning. So we actually went ahead in the last, few years. We've worked on peer zoning and target-driven peer zoning to really make that zoning, piece very easy to do. In fact, even in some cases, you don't even have to do anything around zoning, and the zoning happens automatically. And we did that work in the fabric, in the protocol, in the fabric, right? The second big problem is around, congestion and other areas that we'll talk about in today's presentation. So the engineers, who are, by the way, one of the smartest engineers I've worked with over the years, they've been working on a technology called fabric notifications, right? So Howard Johnson is going to, go through the problem statement and also present the solutions that we've been working on around fabric notifications. So stay tuned, guys. I mean, this is going to be an exciting and a very, very informative session, and we'll be there as panelists to have a discussion after the slides that Howard will present. So Howard, I'm going to hand it over to you.
Thank you very much, Rupin. And Kiran, thank you for the introduction today. I'm very excited to be talking about fabric notifications, which is a new innovation in the Fibre Channel community. But let's take a step back and examine what problem drove us to this point to develop this level of technology. One of the more sticky issues to deal with in networking, whether it's a Fibre Channel or any other type of network, is what I've referred to as a persistent intermittent type of error. And that's that error that doesn't take down any part of the network. It just makes that part of the network difficult to traverse. So, for example, a link that has an occasional CRC error or some type of a physical connection that is marginal, traffic is able to get through, but not at a very good rate. A few frames every now and then are getting hit with an error. What happens is that those kinds of issues percolate and exacerbate overall performance in the fabric. And what we began seeing in the Fibre Channel community is that a lot of the issues that we were starting to see that were becoming customer escalations had to do with these persistent intermittent kinds of issues. The reason that those issues are escalations is because the traditional tools to solve these kinds of things weighed heavily on the expertise of the SAN administrators, storage administrators, and server administrators. And they had to coordinate their efforts based upon a little bit of information based in logs, and then track down what the problem was. A lot of times, these kinds of things would take a considerable amount of time, and meanwhile, the issue is causing havoc within the organization. Over time, various vendors have come up with tools to somewhat mitigate these things, but they still struggled with the overall solution, that is resolving things in a timely manner. One of the biggest areas where we noticed that this kind of a problem could have a significant effect is in the multipath solution. A lot of the higher level software constructs are using I/O to determine that a path is good. And when that I/O fails, it utilizes other forms of I/O test sequences to figure out if the path is okay. And those techniques were very good in the early days of Fibre Channel, but as systems became more complex, speeds got faster, devices provided a lot more functionality, it became less efficient for those techniques to find the problems. And these are the kinds of problems that are found normally with a marginal cable, a bad SFP, some type of inferior connection that made it really difficult for the SAN administrator to locate and then mitigate. And what we found was that a lot of time was spent in the identification and isolation of the issue. Mitigation then, once it was found, was generally straightforward. It's oftentimes it's clean the SFP, reset the connection, replace a marginal cable. Other issues that also started to surface as Fibre Channel fabrics grew in both complexity and functionality was issues that were related to congestion. And these are the kinds of things where perhaps a particular device is asking for more data than it can consume at line rate, or credits on a particular link had been lost, or simply through organic growth of the system, a target port has become oversubscribed. Those are the kinds of things that, again, are difficult things to identify because the problems occur typically when you don't want them to occur, which is at peak workloads, or they kind of come and go. Application comes online, kind of does its thing. You get an oversubscription condition. It causes havoc for a while, and then it disappears because the application is done, and the administrator's puzzled as to how to resolve it. Now, I think Rupin alluded to, why is it that we're dealing with this particular problem now? He alluded to one part of it, which is that Fibre Channel has done a tremendous amount of growth in the last 25 years. A lot of the basic issues have been dealt with, and now we're starting to deal with the much more complex issues, especially as customers' environments have grown. And the other reason is that we've noticed that when these problems occur, that the overall performance for a particular application, especially one, say, with a multipath solution, their performance can actually go near zero. So there are some characteristics of the way storage is accessed. Typically serialized, you're doing a write followed by a read, and you have to wait for the write to complete. So those kinds of operations are serialized. So if the write is sent down a path where you have a persistent intermittent problem, then the response is delayed, and that's what causes performance to decline considerably to an almost a near zero performance level until the issue is resolved. Furthermore, the identification and mitigation tools have evolved over time, and we're at the point now where there's a lot of sophistication built both in the hardware and software that are managing the tools that can be leveraged to help identify these problems in a much more automated fashion. And that's really the last point on this slide, is that customers are demanding a lot more automation in their system. They're experts that are dedicated to keeping these systems running, have a lot of different things that they're trying to manage. And the more things that we in the Fibre Channel ecosystem can do automatically, the much easier it is for them to deploy their solutions. So over the course of the last few years, the Fibre Channel community has gotten together and looked at ways to resolve this issue. And the solution that has come up within the standards community is something called Fabric Notifications. Fabric Notifications consists of two components, a notification component and a signaling component. The notifications and signals leverage the tools that are already built into the fabric. Devices and switches have the ability to monitor the physical characteristics of the hardware, and then they can surface their observations about those characteristics up to the user. Now we want to take and leverage that technology into a mechanism that allows those devices to actually tell each other what's going on. So for example, in the notifications, events are sent to devices that have registered to receive those notifications that'll help efficiently diagnose the particular problem. That is, for example, a switch may detect that a particular port is experiencing a high number of CRC errors. When it reaches a threshold, it can send a message to the devices to say, hey, this particular port has these issues. So let's take a look at it. And that can be sent to all of the devices that would be associated with that particular link. The operation of the notifications is implemented in the form of extended link services, or an ELS, which is more or less a protocol level software function that is being sent between all of the devices in the fabric. Signals are hardware mechanisms that are designed to deal with things like credit stall conditions, where on a particular link, credits either have been lost, or a particular device is not returning credit as it should. And this signal is a mechanism for a transmitter to prompt the receiver that there are resources at the transmitter that are being consumed beyond a threshold, which is essentially saying, hey, I've got a lot of frames waiting for you. You need to take them. It's implemented at a link level primitive mechanism that allows us to be able to send that information even when there's a credit stall or oversubscription condition. This work began in late 2014 as part of a concerted effort by the Fibre Channel ecosystem as we began investigating these particular problems. As I mentioned earlier, customer escalations are really the thing that drove this. And we got to the point where we're saying, look, we have dual fabric environments, and this is the kind of problem that can actually have an impact on a dual fabric solution, reducing the resiliency of Fibre Channel. So we need to come up with a mechanism that, one, identifies what this issue is, and two, allows us to provide a mitigation method so that it can be automatically steered around in the environment so that customers are not impacted immediately by these persistent intermittent issues. Over the course of the following couple of years, we did a lot of research and experimentation with partners throughout the Fibre Channel community. And in late 2018, we started the standardization. Essentially, the ecosystem members got together, collaborated, and started working on mechanisms to standardize the technology needed to alleviate these types of problems. And fabric notifications was the end result of that standardization investigation effort. Throughout 2019 and 2020, the standards community built out a series of improvements to the draft standards. So the framing and signaling standard defines the congestion signals, the link services standard defines the notifications, and the switch fabric standard defines the fabric detection and generation mechanism. We can go into that just a little bit more deeply here. The switch fabric standard, the current draft standard is the -8. That's the working group within the Fibre Channel T11 organization. Our current revision is 1.01. That revision includes a fabric notifications overview for the switch fabric. It describes how the mechanisms are leveraged within the fabric to identify and report conditions that the end devices should know about. It also provides mechanisms for devices to register, or how the registration is managed within the fabric. And lastly, it specifies the scope of the fabric notifications functionality. Furthermore, there's a annex that is currently being added to the revision 1.02 version of the draft standard. They'll provide examples on how to use fabric notifications within the context of the switch fabric. Moving on to the framing and signaling standard, we are at our revision 0.3. This standard defines the congestion signals. It describes that there's a warning and alarm level signal that is available for implementations to take advantage of. It also defines the congestion signal use, how the transmitter detects that its resources have been consumed and starts generating the signal so that the receiver can react to that particular signal. It provides an annex that gives examples of how to generate the congestion signals and when to generate them and what kind of policies can be used based around the congestion signal mechanism. Then lastly, it also defines a new timeout value, which we refer to as the frame discard timeout value. It provides a definition of how end devices in the fabrics can utilize a timeout mechanism for ensuring that frames that are not going to be able to be processed can be dealt with. And then that provides the implementations with tools necessary to alleviate some of the back pressure that can be created when stale commands that cannot be processed need to be discarded to allow frames to continue flowing through the fabric. Finally, let's wrap up here with the link services standard. We're at revision 5.01. This is where the bulk of the fabric notifications ELS mechanisms are defined. It provides a description of the exchange diagnostic capability ELS, which is used to communicate the hardware capabilities of the two devices on each side of the link. So for example, the congestion signal capability is exchanged utilizing the EDC ELS. This standard also defines the registration technique that is used for the end devices to let the fabric know that, hey, I want to participate in this functionality and I want to participate at a particular level. Furthermore, it defines the current diagnostic ELS, which is the Fabric Performance Impact Notification ELS, that is used to provide information to the end devices about things that are occurring in the fabric. So for example, if the fabric detects that there's a marginal link, it can send an F-pin with a link integrity indicator or descriptor to the end devices to indicate, hey, this port has a link integrity issue. And those event types are defined as descriptor values. And these descriptors are structures that provide a lot of information about where the problem is and what type of problem is associated with it. And also what rule was used to trigger the notification. So for example, if the rule is that if a link experiences more than say 2 or 3 CRC events over the course of a minute, then trigger the event, then that rule is defined and described in the descriptor. Lastly, there's also a informative annex in this standard to provide examples of how to utilize fabric notifications and the mechanisms that fabric notifications provide in implementations. So there's a considerable amount of material that is provided within the context of the standard to allow vendors to take advantage of this new technology. So just in summary, the fabric notifications provides congestion signaling mechanism, which is a primitive sent between the transmitter and the receiver. It's signifying that there's a resource depletion that's occurring at the transmitter. Another way to look at that is that there are so many frames at the transmitter that's consuming its buffers, so it can no longer process frames. And we need the receiver to consume the frames, that is to send credit back, so that the frames that are accumulating at the transmitter can be moved on. Secondly, there's the notifications, which are the ELSs, where a lot of the heavy lifting of the fabric notifications is done by providing the ability to exchange the capabilities, register for the functionality, and then report the impacts. So with that, we have the background for the architecture. So let's take a moment here and look at different ways that this architecture can be used to automatically enable improvements in your fabric deployments. At the first level, simply having devices that are capable of registering and just simply logging that these events occurred is a tremendous improvement over what we have today. For example, if a storage device or a server device registers for the fabric notifications and an event is detected by the fabric, hey, this link is not healthy, then that message can be sent to those devices that have registered for it, and then it can be recorded in their logs. When an application user is experiencing an issue and reports it to one of the administrators, whether it's a server administrator, a storage administrator, or even the SAN administrator, this information has been distributed throughout the ecosystem of the fabric, and any one of the administrators can simply pull up their logs and go, oh, hey, I've gotten notifications here that this particular link that's associated with this application has been experiencing persistent intermittent problems. It's got a link integrity problem. Immediately they know, one, what the issue is, and two, where the issue is. So that eliminates a significant amount of the identification isolation component of the problem resolution activity. So now any one of the administrators can quickly identify the issue and get a ticket started to have it resolved immediately. So by simply registering and logging, we've significantly improved or reduced the administrator's time for isolation, identification, and ultimately mitigation. Now, if we take this functionality one step further, and let's take the link integrity isolation example, or condition as an example. Now we have a multi-path solution whose interfaces have registered for fabric notifications. If a link integrity problem occurs, that link integrity issue can be communicated to the interfaces, the HBA, which then surface the message up to the multipath solution, who can automatically take that information and say, hey, here's a marginal link. I've seen that I/O on this link has been difficult because this link bounces between healthy and unhealthy. So now I have a specific piece of information that tells me that this link is suffering from persistent intermittent problems. I'm going to automatically move I/O over to the good paths. And this functionality has in fact been implemented in tools for Fibre Channel solutions and has been demonstrated to be very, very effective. The key thing about this particular solution is that there is no administrator intervention required. That is, the devices automatically register for the receiving the link integrity notification. When the fabric sees that there's a link that has a particular problem, it generates the message that gets automatically sent to the device, who then surfaces it up to the MPIO layer, and the MPIO solution automatically does the failover. This solution takes into account that this is a degraded link and not a failed link. And what that provides for the customer environment is that if in the event that all of the available links are suffering from some type of a problem, the degraded links can still be used to send I/O, although at a much lower performance level, they still have that level of connectivity. So connectivity is not lost, it's just optimized by the MPIO solution. So this is a significant improvement over registration and logging, because we provide a level of automation that is now available to customers to deploy in their environments. Another way to look at the power of fabric notifications is in the case where you might have a target credit stall condition. And this is a case where that can occur at times when a target has been oversubscribed by a number of initiators, which is generally due to organic growth. That is, as the system has grown, more and more initiators have been zoned with a particular target port, and there hasn't been time to refactor, if you will, the fabric. So now the fan-in ratio is much beyond the best practice level. Some applications kick on, all of the servers decide they're going to access that particular target port, and all of a sudden that target port is inundated with commands. The command queue, the unsolicited command queue at the target can fill up, and that can put back pressure into the HBA, which then puts back pressure into the fabric and starts causing congestion issues for everyone. Those congestion issues impact other flows which are unrelated to the particular target port. So you have victims of that congestion. By being able to detect that particular condition, these notifications can be sent back to the servers to say, hey, we've consumed all of our resources here at the target, and we need you servers to back off. So Fabric notifications can be utilized by the end device by transmitting the resource contention issue to the Fabric, who then distributes that notification out to the zoned-in devices associated with that target port. Furthermore, the target port can take advantage of the frame discard timeout value and actually start to discard some of those unprocessed commands and allow natural recovery to resend those commands. By utilizing the two mechanisms of the FDTOV and the notification mechanism, we're able to automatically alleviate the congestion condition, the oversubscription condition at the target, and alleviate the problem of impacting victim flows within the Fabric. And all of this is done without administrator intervention. Another scenario or use case that we can look at is the read oversubscription scenario. Now we have devices that have registered for Fabric notifications, and they are told when, hey, you are trying to consume more frames than you can process at line rate. Now, when a server gets that type of information back from the Fabric, that server can start throttling back the number of requests that it makes until it's reached a point where it's now processing things at line rate. If a target sees that a server is read oversubscribed, it can also take the action of doing speed matching. That is, it can say, hey, I'm operating at 32 gig, but that server over there is asking for a lot of data, but he's only operating at 8 gig. I'm going to pace IO back to him at an 8 gig rate. And now the target has added to the ability to mitigate the particular problem in an automated fashion. In the case of write oversubscription, the targets are also able to utilize throttling techniques by being able to indicate that there's a resource contention. And there's also the notification at the server side who can say, oh, I'm sending too much data to this particular target port. I need to throttle back as well. So it's kind of a symbiotic relationship between the read and write oversubscription behaviors. And again, you have both the targets and the servers taking automated actions in order to alleviate the problem. The key thing here in both of these oversubscription scenarios is that they're trying to reduce the impact that oversubscription has on the overall system. And that is, they're trying to eliminate the cases where a particular device will be impacted by it. That is a victim flow device. Finally, we have our array-to-array replication. And this is where the storage devices can automatically be told about the persistent intermittent problems on a particular path between two arrays, and it can automatically shift the load to other paths that are associated with the array. And that way, the performance and resiliency of array-to-array replication can be maintained, even though there may be a particular path that is suffering from impacts. And at this point, I would like to open things up to our panel discussion. I really appreciate the opportunity to give you guys a summary of what the Fabric notifications is all about and the work that the Fibre Channel community is doing.
Thank you, Howard. I'm going to end the slides now so we can go back to our video presentation. Thank you. It was a great presentation. Thank you guys for joining. We are receiving a lot of questions online, and we also have received questions before. So I'm going to just go through some questions. Again, keep typing your questions as you have in the chat in the question window. And if we can't get to it because we are like only 20 minutes to answer many of these excellent questions, we'll basically make sure you get the questions at the end. I also need to actually, we'll do that later. I need to actually, we have a link to the presentation where it'll be uploaded to and all that. We'll do that housekeeping at the end. So the first question actually is for Mark. Mark, what do you think? Basically, how should you expect devices to react when there is a congestion notification? Maybe you can talk to that a little bit.
Well, yeah, thanks for the question. I mean, in the case of oversubscription or congestion, I mean, devices, obvious endpoint devices can register to the switch so that they get the notification. So that's key. And then once they receive the notification, they can do a variety of things. One of them could be they could be turned off and do nothing, or more likely log it, log the information or send that up the stack so that the upper layers of the, in the case of a host, like an operating system, can deal with it, perhaps MPIO or something. Or they can do something themselves right at the port, and that, at least for oversubscription, makes a lot of sense, because then it can throttle itself at the port very quickly as it reacts to the incoming notifications, and sort of create this feedback loop where you're constantly optimizing and keeping traffic running smoothly without creating oversubscription. So it's probably best to handle this port to port and deal with it there. But certainly there's a lot of opportunity to do things up the stack as well.
Right, it just basically adds a lot of SAN intelligence into your own entire infrastructure to actually take care of it using the scripting or Python scripts and REST APIs that are available. Yeah, that makes sense. That makes a lot of sense. The one more question we received is basically, can you give us a little bit, like, what works best for IOs? Like, what is the holistic view of like congestion reduction? How should we think about it? Maybe Nishant, you can take this and help us understand that.
Sure. No, thank you, Kiran, and great presentation there, Rupin and Howard. Very informative. I know, Howard, you've done a lot of work around getting this to where it is. So thank you for all of that. So to answer your question, or the audience question, if you look at a holistic view of congestion notification, I'll add to what Mark said, right? The fundamental principle behind this starts with that visibility is key. Right. The fact that something is going on in the fabric that could affect individual devices either now or after a period of time, it's important to notify people, right? And different device points, whether it is the HBA in the server, the fiber channel switch, or a target device, everybody can take some kind of corrective action, right? But it is very imperative to understand that any actions that individual device takes, whether it is throttling of IOs down, whether it is choosing a different path, whether it is going to a different link rate or other similar mechanisms, it's very important that these actions are adaptable, right? So that the devices continue to listen to see whether these notifications are continuing to come in, they have gone away, so they can adapt their response. In absence of this adaptable mechanism, IOs could come down to a screeching halt, which is not what any customer wants, right? And end of the day, the goal of like in our work life, right? We receive these notifications, adapters receive these notifications. Their goal is not to let things escalate. These problems, if not addressed via throttling or path failovers and such, will escalate to the SCSI stacks, to the applications, which make them much more harder to solve. And finally, at least my view on this is that while there are different devices which can take different actions, they all should work in collaboration, be responsive, because cost of inaction, of just taking a notification and not doing much with it, is worse than acting on it in a conservative fashion.
Right. I mean, it's just basically, it's better to act on. It's always better to act on things that you basically are notified, right? So that's one of the most important things that an administrator can do. But many times they don't have the visibility. So this actually kind of provides the visibility so that they can act on it. It's a good, I mean, alarming notification is like, I think it's sort of not a follow-up, but it's a little bit of more getting into the details of it, I guess. But a question is, any alarming notification is only as good as the personnel being notified. Many at a time, many a time the current SAN switch alerting features are sending notifications. So like SNMPs and all that. Uh, how's the new Fabric notification platforms overcome a failure to respond? I guess maybe that's a question. Howard, can you take it and help us with that?
Yeah, absolutely. I think this actually encompasses a broad range of questions. Certainly, one of the things that we were looking at when we developed the architecture of Fabric notifications is the ability for devices to react to it. And that's what the registration mechanism is for. And in fact, the registration mechanism provides a way to be able to deploy this functionality into either existing configurations or deployments or greenfield, however you want to look at it. Because what you can do is you turn on the fact that you want to register to receive these notifications. And then by doing so, what the device is saying is it's telling the Fabric, hey, I can receive these notifications and I can do something with them. The device is not inundated with notifications that it's incapable of handling. So as you start deploying these new devices with this new capability throughout your Fabric, it becomes additive. That is, you may zone together, for example, a set of devices that are Fabric notifications capable, and deploy applications on those devices in that particular zone, so that they can operate at a very effective with a very effective mechanism, which is the Fabric notifications functionality. And then the other element of the Fabric notifications is that it provides you a mechanism to be able to understand the difference between different types of behavior. That is, it provides you a mechanism to know when I/O is impacted by a persistent intermittent problem. That's a link integrity event. It provides you a mechanism to know when you are the congesting device, that is, your read over subscribe, for example. So that's the congestion notification event. It provides you with a mechanism to know when something downstream is creating the congestion. That's the peer congestion notification event. And it provides a mechanism for indicating when a command has been discarded for some reason, whether it's an FDD TOV or within the Fabric because it's unable to deliver it. That's the delivery notification event. So each one of these event types provides different levels of information for the devices to act on. And the registration mechanism provides the Fabric the information to say that the device is ready to act on them. So that's what I think is the beauty of Fabric notifications in that sense, is that it can only work on what it is capable of working on, and it lets you know when it's ready to handle it.
Yeah, no, this is good. So one quick question, actually, we'll come back to the readiness of the whole thing, but like many vendors have their own playbooks, basically Ansible playbooks, or maybe Python libraries available for their own specific solutions and all. Is there any particular suggestion? There is one mention of Dell EMC Ansible playbook. Is that the go-to guide for that, or is there any others one? Maybe Rupin, would you be able to help us with that?
Yeah, I mean, I think if you just go to Google and you type in, Brocade, Brocade Ansible playbooks, you'll find the link. The first link actually is the right link. Same thing if you go and say search for Cisco MDS Ansible playbooks, the first link you'll find is you'll find a lot of the downloadable. And I think similarly you can go and down the link down for every vendor. You'll find that every vendor, HPE, I'm sure Dell also has their own set of Ansible playbooks. So you can depending on what infrastructure you have, a lot of customers I talk to have, generally speaking, multiple vendors. So you can pick and choose.
So I'm feeling lucky is the button you should press on Google, huh?
That's right. Well, actually, for Brocade, yeah, it's the first link was. I think even for this was the first one, yeah.
Yeah, I'm sure. Yeah, I think yeah, we get to, yeah, I think the SEO is improving everywhere. So that's the big thing going on in the background. But so I think this question for everyone here, I think it's an important question, is what is the state of readiness of storage ecosystem? Like, HBAs, we have representation from switch companies like Howard are here, HBAs, even storage, Rupin is here, HBAs, Mark and Nishant are representing. What do you guys think? Where is Fabric notification today? How do you see it getting rolled out in the market and all that? Maybe we can start with let's say Mark, I guess.
Sure.
He's on the top left corner.
Yeah, sure. Well, I mean, we're all working on it, and I think looking at the breadth of everybody's products out in the marketplace, it makes sense to work on the current generation products. So I think you can assume that Gen 6 forward devices or whatever is current device for you is probably where you'd start implementing this. And it's mostly implemented in software. So, if you've purchased those products already, they can be updated when you update your drivers, either their inbox with the operating systems as they roll out with them, or download out of box drivers. But you can gain that support today, and pretty much have it.
With the shipping products, looks like.
Yeah.
Yeah.
The latest stuff, the latest generation.
Yeah. Nishant, would you like to add something?
Sure. So I think I agree with whatever Mark said here, but I would kind of harp upon one important thing, which is that it should not be assumed that in order for you as a customer to get the benefits of Fabric notifications or FPINs, every single device in your Fibre Channel SAN must be capable of receiving Fabric notifications, right? The more the devices that you have capable, the easier it will be for the entire coordination and visibility to work. But this is not, this is a heterogeneous world where you can have, as long as you have the Fibre Channel switches, whether it is from Brocade or Cisco, which have the capabilities to generate Fabric notifications, you could have some initiators and some targets which have the capability to register for these notifications, get them, and take action. There could be others that do not have that capability. It's perfectly fine. This is not something that you need end-to-end, which means your initiator, your switch, and target, everybody needs to support it. Otherwise, you will not get the benefits of it. That is not true. So please, as you have, like Mark said, a modern 16 gig Fibre Channel, modern 32 gig Fibre Channel HBAs, make sure you get to the latest firmware and drivers. Support exists across major operating systems, Linux, Windows, VMware. On the host side, you will see that adapters registering for these notifications, getting notifications. With regard to actions for notifications, and that is a developing world, right? For example, as far as I am aware, most HBAs would register for these notifications and get them. And for actions specific, there are some early actions. For example, logging will happen today. There will be in the future actions like throttling IOs. There could be actions which are failover, which requires some multipathing arrangements and things like that. So it's like Mark said, it's a developing world. But the important point that I want to say is, don't wait for the world to become perfect. This can start benefiting you, on an individual component basis.
Yeah, just to add one point to Nishant's thing, just to tie it together. It's a good time to move off of some of the older technology, that doesn't support that. Maybe you don't want those older 8 gig, 4 gig HBAs causing problems. Time to move up.
You bet.
Yeah. It'll not be implemented on the 8 gigs, I'm sure, but yeah, it's too much to ask. I think is there anything more to add, Rupin or Howard? Or I have one more question that I think we can tackle here.
I would like to add to both of what Mark and Nishant have put out there, and that is one of the wonderful things about Fabric notifications is the ability to incrementally add the functionality. The registration mechanism is a thing of beauty that allows you to deploy the functionality in and get different parts of your system exploiting the functionality. The other thing I wanted to add is that the Fibre Channel community has been very active in the Linux open source community in order to bring this functionality to not just Fibre Channel products, but out into the operating system products. And we've got released products out there from the open source community, as well as also vendor-specific operating systems that are deploying Fabric notifications already. So the functionality is there; it's ready to be exploited, and it's a great opportunity. The storage community is really embracing it. Every piece of the component moves at a different level, and it's the architecture that I find very key to this has been this registration mechanism, so that each piece can come in and start playing when they are ready.
Awesome. So I think one more question. That's I think. We'll take this last question online. But what does the future look like with these constructs? Where are the opportunities for this? What's the next step really? Like, what's the future looks like? Maybe we can start with Rupin this time, and then go for this question for everyone really. But maybe start with Rupin.
Yeah, we're going to continue innovating in this space. I think this is a SAN automation and solving the complex problems that we discussed today in this call. We're going to continue attacking these problems and solving them. I think the Fibre Channel community actually gets things done, and we're very proud of all that. And so we find a problem which we believe is prevalent in our customer base, and we actually end up solving it. And that's the reason why Fibre Channel continues to remain the #1 protocol for storage connectivity, and because of its reliability, its robustness, and et cetera. So I think as a team, I'm very proud of the team, working as a team, across the industry, and we'll continue to solve more problems and continue to develop this particular solution. It'll take time, like we discussed in this call, because it's really the whole village has to come together, including multipathing layers, operating systems, storage, adapters, etc. So it'll take some time, but you know what? These really big problems are not solved in one day. And as a community, I think we're going to continue not just progressing on what we discussed today with FPINs, but also identifying new areas of development.
That's great. So no, this is good. I think you get the last word on this. Do you want to add something, Mark?
Yeah, just to add
Please.
tail on to Rupin's comment. There's also a fantastic opportunity for vendors outside the traditional Fibre Channel community to take advantage of some of this information that could get passed up through the host. I mean, imagine when we talked about multipath vendors, but also cluster awareness, hypervisors. I mean, there's just a lot of places this information would be really valuable to ensure that everything's running as efficient and congestion free and getting that real-time SAN information. So I'm pretty excited where this could go outside of our industry too.
Yeah.
Sure. No, let me quickly add to that. To me, like what Howard said is the foundation, right? The fact that different SAN components have visibility across what's going on in the fabric is just the foundation. And solutions that can be built on top of that is everything that Rupin talked about, right? Whether it's orchestration, whether it's intelligent diagnostics. So you will see a lot of smart stuff built on top of this, right? And everything will work together, right? All the vendor solutions will be able to work together to solve your problems. And to your question, Kiran, what I look forward is fewer customer escalations and sleeping better at night when customers' workloads run without these intermittent problems. So
that's our mission.
Here.
Yeah.
Everybody get a good night's sleep.
Exactly.
That's right. That truly is one of the really cool things about the technology is that this level of automation allows administrators to deal with these kinds of issues in a planned fashion rather than having it boil up into an immediate escalation. So the automation underneath mitigates the issue. It records the fact that it's there. The administrator can say, okay, here's a task I can do tomorrow during my lunch break, rather than, oh gosh, I've got to stay up all night, figure out what this is in order to get things up and going, because the system's running. The devices that are participating had taken care of the issue. They mitigated it. Everybody should be happy and getting a much better night's sleep.
Here. All right. Thank you, guys. I think we'll take the rest of there are a bunch of more questions. Actually, we'll take the rest of those offline, and then we'll post those questions on the blog or something. I'm just going to go back to slides quickly and talk about the some resources that are available. Okay, so if you go to we do a lot more webcasts on FCIA. All of them are recorded and actually uploaded also. But if you want to register, go to fibrechannel.org/webcasts basically, and you'll see a lot of the older ones as well as the new ones that we'll be doing. Along with that, we have the solution guide that we publish every year with excellent articles and information. And so if you go in last year's actually solution guide was published, and it's at the link on the right side. The slides themselves are available for you to download also from the presentation here itself, or well, basically you can go to fibrechannel.org and you can get the slides there. After the webcast, please do rate this event. We really value your feedback. Helps us with presenters, with new topics that you want to listen to. We'll post the QA on the blog at again fibrechannel.org site, and do follow us on Twitter. If you have any questions, you can always tweet the questions to us, and we'll do our best to answer those and get you the information you need. Finally, we also have a YouTube channel. A big link there, actually, Fibre Channel Industry Association, FCIA, on youtube.com. Follow us, just search for FCIA Fibre Channel. I think you'll get that. And then that will get you to the link. So thank you everyone for joining. Really appreciate it. And I appreciate your time. Appreciate time of the presenters. Great presentation. Great job, guys. And thank you for your time and being available. Thank you.
Thanks,
Bye-bye.
everyone.
Thank you, Kiran.
Bye.
Thanks, everyone.
Bye-bye.
Bye now.
Bye, folks. Thank you.